We're going to use differentiation to find the equation of a tangent. So just before we do this whole process, I just wanted to recap what a tangent is to a curve. So if we have a random curve and you want to find the equation of a tangent at this specific x coordinate, a tangent is a straight line that meets the curve at exactly one point. And the key term that relates the tangent to the curve is the fact that if you find dy dx of the curve at that point, so if you find dy dx and then substitute whatever x value is at that point into dy dx, that will give you not only the gradient of the curve at that point, but also the gradient of the tangent at that point, which is the m in this equation. And because the tangent is a straight line, it's in the form y equals mx plus c. So let's go on to actually finding it. So I've made a few prompts here. You can have a go at a question if you'd like yourself. Dy dx, when you differentiate the curve, that will get you an expression that tells you what the gradient of the tangent is at any point. So let's do that. You do the power times the coefficient. 3 times 2 is 6, x, and then subtract 1 from the power. So let's do that each term. When you differentiate 5x squared, it's 10x. And then when you differentiate minus 7x, it's just minus 7. When you differentiate a constant, it just goes to 0. The reason for that, by the way, is because this is the same as 10x to the power of 0. And when you multiply 0 to this coefficient, 0 times 10 is 0. So that's why the term ends up becoming 0. Great. Now, this is an expression that gives the gradient of the tangent, but because we want the specific gradient equation of the tangent when x equals 1, we can put x equals 1 into dy dx, and that will give you the gradient of the tangent to this curve when x is 1. So let's do that. So it's 6 multiplied by 1 squared, which is 6, plus 10. You can always just put this in a calculator if you have your calculator available to you. And that's equal to 9. That tells you that the tangent, it has a gradient of 9. But we still don't have the value of plus c. In order to find the c, we need a coordinate that the tangent crosses through. Now we know the tangent meets the curve when x is 1. So if we find the y-coordinate of the curve when x is 1, we can use that as the y-coordinate of the tangent. So let's do that. So when x equals 1, the curve y is equal to 2 times 1 cubed, which is 2, plus 5 times 1 squared, which is 5, minus 7 plus 10, and that just equals 10. Meaning the coordinates where the tangent meets the curve is 110. Now that we found a coordinate that the tangent crosses through, we can replace x and y in our equation of the tangent with that to find the value of plus c. So 10 is equal to 9 multiplied by 1, which is 9, plus c. Taking away 9 from both sides, we get c is 1, and then our final equation is y equals 9x plus 1. Great. Hopefully that makes sense. If you enjoyed the video, please like, comment, and subscribe, and turn post notifications on. I'll post a new video every day, and I'll link my email in the description as well in case you have any tutoring inquiries.